Hi everyone, this is a video about lesions affecting cranial nerves 3, 5, 7, and 9, in particular with the context of what happens when a lesion is located on a nerve of cranial nerve 5. Remember that cranial nerve 5 carries autonomic fibers for cranial nerves 3, 7, and 9. There's a few principles to understand before we get started. So let's zoom in here. The first of these principles is that the pathways of the nerves matter. So, pathways matter. And that is that depending on the course of the nerve and through the skull, the trauma that can occur, or tumor that can occur within the skull, can affect particular nerves and particular pathways, especially when we go through special spaces. The second thing is that the fibers through that nerve matter. And so that's referring to whether we're talking about just sensory or motor fibers of cranial nerve 5, or if we're talking about the autonomic fibers for cranial nerves 3, 7, and 9, and also their locations. So fibers matter. And then finally, as I was alluding to just a second ago, the location of the lesion matters. All right, so let's take a look at what I'm referring to here. Let's start with V1. So this is a map of V1. V1, there we go. And V1 is the ophthalmic nerve, and it courses through the orbit to terminate as the supratrochlear nerve and the supraorbital nerve. We'll draw V1 fibers in, let's say, purple. So here's the supraorbital nerve and the supratrochlear nerve. It also gives branches, the nasociliary nerve, and those branches are going to different parts and sides of the eye. The nasociliary nerve courses on the medial border of the orbit, medial wall of the orbit, and gives ethmoid nerves, anterior and posterior. It also branches as sensory root, which is going to innervate the eyeball. There is a lacrimal nerve that's going to go to the lacrimal gland. This is pulled out here. All right. Let me draw on the supratrochlear nerve and the infratrochlear nerve and the supraorbital nerve. There we go. Okay. Now, notice a couple things. First of all of these nerve branches are sensory to the regions of the upper face and the orbit and the eyeball. And the lacrimal gland. All of them are sensory. But there are some places where we have some funny innervation. Let's start with cranial nerves 3. I'll draw that in yellow here. Cranial nerve 3 also sends fibers to the ciliary ganglion, which sits here. And notice that it uses the fibers, the nerves from 5, to be able to get to its target, which is the eye. So, cranial nerve 3's fibers are coming from the cranial nerve 3 itself, which is coming from up here, not drawn in this diagram, and innervating the eyeball. So, if I have a lesion, we'll draw a lesion in our funky colors. If I have a lesion of fibers in cranial nerve 5 that are already carrying cranial nerve 3, so let's say the short ciliary nerves here, then the parasympathetic innervation of the eye is going to be affected, as is the sensory innervation from the same region that was innervated. Let's talk about cranial nerve 7. That might be a little bit more clear. We'll draw cranial nerve 7 in green. So cranial nerve 7 sends a branch, postganglionic fibers, up the communicating branch from the zygomatic nerve to the lacrimal gland to provide visceral motor innervation of the lacrimal gland. Where does this come from? Cranial nerve 7 fibers, if we zoom down here, here's cranial nerve 7. Here are the fibers from cranial nerve 7. Here are the preganglionic fibers that go through the geniculate ganglion but don't synapse there. Then they enter into the pterygoid canal to synapse here at the pterygopalatine ganglion, which sits in the pterygopalatine fossa. Postganglionic fibers travel from the ganglion to V2 and travel via the communicating branch of the zygomatic nerve up to the lacrimal gland. So if we can see that also here. Here is the pterygopalatine ganglion. So the nerve of the pterygoid canal, pterygopalatine ganglion. So nerve of the pterygoid canal is going to come through here, synapse at the ganglion, and then go to the zygomatic nerve right here. And it's at this point where it joins here in the orbit. So we could have drawn a line this way. And here is the ganglion. And the fibers coming from the Vidian canal or the pterygopalatine canal came that way. So these are preganglionic over here, and these are postganglionic. Okay, so what does this have to do with cranial nerve 5? Well, if a lesion of cranial nerve 5 to the lacrimal gland occurs here, that is only going to affect sensory fibers from the lacrimal gland going back to the brain. Cranial nerve 7 doesn't hop on until later to that, distal to that point. So I would need to have a lesion here in order to knock out the visceral motor fibers to the lacrimal gland and sensation from that gland. If my lesion was on the communicating branch here, then I would knock out visceral motor fibers to the lacrimal gland, but maintain general sensation, fine touch, pressure, temperature, vibration from the lacrimal gland. So where the lesion is located along the pathways to a particular structure does matter. Lesion location matters. So let's take a look at another example. So let's take a look at the cranial nerve 7 taste fibers. So the nerve that is involved here is chorda tympani. Chorda tympani courses from the middle ear cavity, and we'll cover a little bit more detail of that in a second, and will join with the lingual nerve here. Well, chorda tympani is carrying two kinds of fibers. The first is drawn solid line here, which would continue down the lingual nerve, is going to go to the submandibular ganglion, right here, submandibular ganglion. And from the submandibular ganglion, it will innervate the submandibular gland and also the sublingual gland. Those are parasympathetic visceral motor innervations of the gland. But the other thing that runs with chorda tympani, I'll just draw dotted here, are taste fibers for the anterior 2/3 of the tongue. All right, well, what else is going to the tongue? Well, cranial nerve 5 is also going to the tongue. So let's draw, actually those are purple. So the sensory fibers from the lingual nerve are traveling here and also going to the tongue. So this is sensory. All right, so let's put our lesions in here. If I have a lesion of the lingual nerve at this point, then that knocks out sensory, taste, and innervation of the submandibular gland. If my lesion is proximal to the lingual nerve, from where chorda tympani joins, then the only thing I lose, actually I'll do this, if my lesion's here, then the only thing I'm going to lose is sensory to the anterior 2/3 of the tongue, because the fibers from the chorda tympani nerve are unaffected by that lesion. On the other hand, if my lesion were, choosing our color here in chorda tympani itself before it joins with the lingual nerve, then I would lose taste to the anterior 2/3 of the tongue and visceral motor innervation of the salivary glands. Well, we can add one more lesion into this story. So let's put it here in the tongue. So what would we lose here? Well, we would lose taste for the anterior 2/3 of the tongue, sensory for the anterior 2/3 of the tongue, but salivation would be maintained because those fibers have already hopped off of the nerve. So that's the principle of lesion location. Just to let you know, chorda tympani came from here, and I'm going to show you that route in a second. Okay, this is the facial nerve. So let's go down to this image. Here are my facial nerve fibers, and I'm going to draw them in a different green just so we can see them better. So here are my facial nerve fibers. They will travel again through the geniculate ganglion, but not synapse there. This is carrying both taste for the anterior 2/3 of the tongue and also visceral motor. So I'm drawing the visceral motor part that's going to synapse at the submandibular ganglion and innervate the submandibular gland and the sublingual gland. And now I'm going to draw in taste, dotted line. There we go, to the anterior 2/3 of the tongue. And remember that sensory fibers are traveling with the lingual nerve. Will travel this way. Okay? So let's take another look at 7. Now this view is of the middle ear cavity. And what I love about this view is it shows cranial nerve 7 coming from the internal acoustic meatus and by the middle ear cavity. So middle ear. So cranial nerve 7 is this nerve, and it travels into the cavity like so. The geniculate ganglion is out here somewhere. There we go. The motor root of 7 will continue down to the face. So this goes to muscles of facial expression. But the chorda tympani fibers go this way, and they go around the tympanic membrane, and this will go to lingual. But remember that we are also carrying the taste fibers to lingual. So that's 7. We'll come back to this drawing in a second because it's going to be important for understanding cranial nerve 9. Oh, speaking of which, let's talk about the motor fibers for 7. So this point right here is at the stylomastoid foramen, which is the same point right here through the stylomastoid foramen. Here we go. Lesions to 7 are either at the stylomastoid foramen or typically within the internal acoustic meatus, are going to affect the downstream branchiomotor fibers to the muscles of facial expression. So here, the lesion, if the nerves are going all sorts of different directions here, the lesion would be knocking that out, which causes Bell's palsy, which is an ipsilateral drooping of the face. Now notice, would fibers from 7 be affected that are not motor? No, because here is the stylomastoid foramen. So if my lesion, fibers going this way, if my lesion is here, let's just say it's right there, it will not affect taste or innervation of the salivary glands located in a completely different pathway. And it would certainly not affect lacrimation of the eye. All right, so now let's take a look at cranial nerve 9. Cranial nerve 9 does all sorts of different things. So cranial nerve 9 will go through the foramen ovale here. We'll draw cranial nerve 9 in a different color. How about this color? So cranial nerve 9 ends up going through foramen ovale, and its objective is to get to the parotid gland. Well, let's start this. So the parotid gland is going to sit actually over here somewhere, and so cranial nerve 9 needs to send its innervation to that point. So it goes through the foramen ovale, and it will hop onto the auriculotemporal nerve after synapsing in the otic ganglion. So it goes this way, and it will innervate the parotid gland through the auriculotemporal nerve. Well, that auriculotemporal nerve is a super important landmark because it just so happens that it is also located, this loop right here is where the middle meningeal artery comes in and goes into the skull. So we'll just write here to skull. And in fact, this is the artery that is traveling in the epidural space between the endosteal layer of the dura, or the periosteal layer of the dura, depending on what you want to call it, and the meningeal layer, between the periosteal layer of the dura and the skull. And a bleed of this artery is going to cause an epidural hemorrhage between the dura and the skull itself, the bone. So let's look at cranial nerve 9 down here. So the story here begins with this little nerve called the tympanic nerve. The tympanic nerve emerges from the parent cranial nerve 9 fibers, and it enters into the middle ear cavity. So here, I'm going to draw this like this. Here's the jugular foramen. So jugular foramen. Oops. And cranial nerve 9 comes out this way and sends its tympanic nerve here. Tympanic nerve. So this is tympanic nerve, and it goes into the middle ear cavity and does this weird plexus at the tympanic promontory and emerges as the lesser petrosal nerve. That lesser petrosal nerve courses through the middle ear cavity and comes down into and through foramen ovale, whereupon, as I showed you in a bit, or previously, excuse me, that it went into the otic ganglion, synapse there, and then continued on. Let's see, we'll draw it this way. Continues on via the auriculotemporal nerve. I'll draw the little line there. Via the auriculotemporal nerve to the parotid gland. And remember that the middle meningeal artery travels this way to get to, it goes behind the ear here, to get to the skull. Actually, it'd be in front of the ear. So let's do this. So to inner skull. Alright, so if we take a look at that figure again, this view of the box of the middle ear cavity is looking at it from the front. This view is looking at everything from the side. So you can see, I should use this color, the lesser petrosal nerve would have come down this way into foramen ovale and continuing with the with the auriculotemporal nerve and the parotid gland. Okay, so that's 3. Cranial nerve 3, 5, 7, and 9. So remember the principles: the pathways matter, the fibers matter, and where the lesion is located matters. Alright, I think that's it for now. I hope that was helpful.